Greetings and welcome, friends. Mr. Waddy here. We are talking today. We're continuing our look at scatter plots and best fit lines. Today's lesson is called Analyzing Lines of Fit because, like we've noticed, we each kind of have been coming up with different lines, different models that represent our data, in general, on average. And so one of the ways we can kind of evaluate how well a line represents the data is to ask the question, how far is my data from my line, right? Like, are all of my points far away from the line that I said represented them well, right? So how far away are my points from the line? And so these distances are called residuals. A residual is the difference of the y value of a data point and the corresponding y value using the line of fit. So this data point right there, let me give it a, all right, would have been some sort of x1, y1 from our graph, okay, our scatter plot. And then I would have made a line and I could have predicted a y value. All right, so this would have been my, I guess, like predicted x and comma the predicted y. All right, is kind of what that ordered pair is. And now the question is, how far away is y1, the actual point, to my predicted y value for that point? Okay, so that's what a residual is. And let's see, a residual can be positive, negative, or zero. So it's possible that like a positive residual is when I do y1 minus my predicted y value, and it's got a positive difference. If it was underneath the line, then it'll be negative. And it's also possible, right, like we've seen that sometimes a data point just happens to land right on our line, and it's like, hey, right, I hit it, dead on, perfect. Okay, so the residual would be 0 in that case. So a scatter plot of the residual shows how well a model fits the data set. If the model is a good fit, then the absolute values of the residuals are small, right? If in general these distances were small, then my data is close to my line and my line is a good representation of it. But if the residuals are larger, the points will be more scattered, right? Wildly scattered. And it might even suggest that there isn't a relationship. It might even say that there's no correlation whatsoever. So let's use some residuals to kind of estimate how well an equation represents a line. So here's example 1. It says using residuals. It says in example 3 in section 4.4, the equation y equals negative 2x plus 20 models the data in the table shown. Is it good at doing its job? Is it a good fit for the data? And so I've given you guys a little table. I've actually made an extension to the table on mine. I'll have you guys make the same extension. All right, so here we go. So you're going to add 2 more columns to yours if you have space. Did I give you space on the side? Did I even give you a table? I don't remember. All right, I didn't color match very well. Yeah, that's fine. Maybe in the future someday. I also didn't font match the greatest. But here we go. Here's my inputs. Here's my outputs. And then we had an equation, y equals, right, y equals negative 2x plus 20 was the equation. And so what I'm going to do is figure out, okay, here was the actual y value. Let's figure out what would my equation have predicted was the y value. Okay, so I'm going to do negative 2 times 1. Let's see, I'll give myself some space. Negative 2 times 1 plus 20. And we'll see, is that going to be 19 or something close to it? So let's see, negative 2 times 1 is negative 2, plus 20 is going to be 18. So that would have been my predicted y value. That would have been a point on the line, but notice it isn't 19. Now to find my residual, what I'm going to do is take that 19 and subtract that 18. So 19 minus 18 has a residual of 1. okay? So I'm finding out how far away was the real point from my predictive model. So let's find some more. So negative 2 times 2. I'm going to do some of this arithmetic fast just for sake of time so we can get into more interesting things. Negative 2 times 2 is negative 4 plus 20 is 16. And I would have done 15 minus 16 equals negative 1. So in this case, it was actually under the line, right? That was a negative residual. All right, let's do plug in 3. Negative 2 times 3. If you don't have to write out all of the work here. If you just write out the numbers, that's fine. As long as for the first couple you saw where we were getting those numbers. So negative 6 plus 20 is 14. And I'd have 13 minus the 14, right? So 13 minus the 14, my actual versus my predicted. And I get negative 1 again. Aha. Aha. Excellent, excellent. Right? So I'm just seeing where this goes. Now, I happen to know that since the slope is negative 20, and since these are counting by ones, that this number is just going down by 2 every time. So this is going to be 12, this will be 10, this will be 8, this will be 6, and this will be 4. And now let's see what we get. 11 minus 12 is negative 1. 10 minus 10, oh, we got one. We got one, friends. Nailed it. We got it, right? That the predicted value perfectly hit the expected value. 8 minus 8, another one. Wow. Whew. Can't believe it. Can't believe it. 7 minus 6 is 1. 5 minus 4 is 1. And so here we see these residual values, and we can then say, because these are small-ish, right? Those are small-ish with respect to the data. I mean, that is like $1 million. That's kind of a lot. I guess you don't want to be wrong when it's $1 million. But yeah, bless you. But the points are kind of distributed pretty well, that we would say that this is a good representation of the data. Let me show you on my table. Let's see, do I have example 1? I'm on example 1. Now, so you guys can open up your example 1 as well. My students are here with me. And my y value, what was my equation? My equation was y equals negative 2x plus 20. Let me show you how I can program. Guys, this is so great. You're going to learn how to program a formula in a spreadsheet. This is a really big day for you. Do you have 4.05 data? Is that? Oh, you got to open the other one. So that at the front page of the worksheet you're on right now, on the packet, type in a new link. All right, so there's a new link there, and then make a copy of it. So flip to the front page, and it'll take you to this. It's okay, you can just follow along for this one, and then the next example you'll have it, as well as for all the homework problems and practice problems. All right, so if I want to use y equals, right, because my predictive equation was y equals negative 2x plus 20, watch this. I'm going to say this cell equals negative 2, all right, negative 2. How do you type multiplication in a computer? Does anyone know? What's the multiplication symbol? Yeah, it's the star, the little asterisk, the symbol above the 8. So hit Shift 8, or if you have a number pad, you guys don't have a number pad on the side of your keyboard. That's what it would be. So I'm going to say this is going to equal negative 2 times x. What is x? X is this number right here, right? So watch this. I'm going to click on this. And notice it says negative 2 times a2. A2 is my x value. What that's going to give me is negative 2 times the 1. And then I'm going to say plus 20, so plus sign 20. And so what I've done is I've typed in a formula using some other cells, and I'm going to hit enter, enter. And notice, bam, it gives me the 18, which is what I had here, right? That's the 18. 18, it matches. And so I've given us a formula using the equation negative 2x plus 20, and instead of x, I said multiply by a2 in this case, which was my x. Now watch this. Now instead of typing that formula a whole bunch, because computers are good at doing the same thing over and over again, reselect your cell, like click off of it and then click on it once. Don't double click on it. And move your cursor to the lower corner, the lower right corner. See how I've got like the arrow and then it turns to a black plus sign? Question, comment? That was already typed in. Click on example 1 down at the bottom. Sorry. Yeah. And you're in the copy of is what you're editing, right? Yep. Good, good. All right. So now that I've typed my formula, I'll show you another formula again in the next example, so don't worry. Move to the bottom corner until it's a black plus sign. Click and drag down. Here, let me come check. But click and drag down and then release, and it will actually calculate all of those values for it. Right. So you need to type the formula. You're doing negative multiply is the R. And we're multiplying by this cell. So if I hit enter, it calculates that for us. Then we can move our, so we get the black plus sign, and then click and drag down. It copies that formula, but it pulls the x value from every other. Negative 2 times, and then you click on the cell you want it to multiply by. Oh, you're in the wrong one. Here. Yeah. Here we go, example 1. There we go. All right, so equals negative 2 times, I'm going to click on the x plus 1. Enter. And now click on this when you get the black plus sign and drag it down to the bottom. We're going to do one more formula. All right, you got yours working? Awesome. Awesome. Let's calculate the residual. What was the residual equal to? That was equal to the original y coordinate minus my predicted y coordinate. So watch this. Click in the top residual cell. I'm going to hit equals. And I'm going to say I want to do 19 minus 18, but I'm going to do that by clicking on the 19 cell. So that says B2. I'm going to type a minus sign and click on C2. I'm teaching it a formula because I'm saying, like, I don't want to do a bunch of subtraction. I'll just tell my computer to do a bunch of subtraction forever. I hit enter, gives me 1. And notice that is what we get for my residual right here. I got the 1. Right? So let's copy that formula down. So black plus sign, drag down. Actually, one of the things you can do, you can even just double click on that black plus sign. And it'll just, bam, copy it down all the way until the last cell. I did equals this cell minus that cell. B2, so click on the cell B2, or you can actually even type B and then 2, and it'll know what you're talking about. And then say minus C2. Enter. Right? And then drag that cell down, or double click on that dot, that square, and it'll copy it down automatically. All right, so we end up getting that. It works out. Now let me see, can I do this? Aha. Notice what I just selected. All right. This is what I want us to do. Highlight the first column, the weak X column. All right, so highlight that column, click and highlight. Now hold the control key. All right, this is a little tricky. While still holding it, click and highlight this column. And notice I've got 2, don't let go of control. Don't let go, Jack. Right? So I'll show you again. I highlighted this column. I hold down control, don't let go, and click and drag, highlight this column. Now let go of control. Oh, sorry, you guys might need to drag. There we go. So, okay, yeah, let go then. Now hit control. I like that. So with those columns selected, Yeah, good, good. All right, all right. So we got one selected. Okay, so we click and drag. That time we let go awesome. Now control and click, drag. And now we're going to hit insert chart. Here we go, friends. Insert chart. And chart types, let's go down to the scatter plot again. All right, so select scatter plot. You guys got it? If you want, you can click on the customization tab, the third tab up. And if you scroll down a little ways, you can edit all sorts of things. I'm going to change my colors, and I'm going to change the size of those dots. And I'll hit insert. And now it puts that chart right in my table. And so these dots are my residuals. Excellent, excellent. All right, I could have given it a chart title, but I didn't. So I'm just going to copy and paste that. So it's actually possible you can make a graph of the residuals. So these are the differences between the actual value and the predicted value, and that's what my graph looks like. And the fact that all of these points are close to 0 means that my model, the model, is a good representation of the data. Since the residuals are close to 0. All right. So if I had some of these like super far away, I would be a little concerned. The fact that I have, let's see, let's actually count them. I've got 1, 2, 3 up above the line and 1, 2, 3 down below. Remember when I said when we draw our line, I wanted to kind of have roughly the same points above and below, roughly? That also is represented here in the residuals. Okay, so the fact that these are close to the origin, close to 0, close to this x-axis, right? That's good news for us. That means our line represents the data well. Okay, let's pick up the pace. So I've shown you a bunch here. Shown you a bunch. All right, let's do example 2. All right, pick up the pace. Pick up the pace. Right, a lot of time in just training, but it's going to be el más fácil del mundo now that we've figured out how to do it. So it says the table shows the ages X and salaries Y in thousands of dollars of 8 employees at a company. The equation Y equals 0.2x plus 38 models the data. Is the model a good fit? So let's switch over to our spreadsheet. I'm going to click down on example 2. Ooh, excellent. Example 2. All right, hey, there's that same data. And in my Y value from model, I'm going to type equals in that cell. Now, what was the model? The model is 0.2x plus 38. So I'm going to type, after that equals, I'm going to do 0.2 multiplied by, and where's my x value for this row? My x value is that 35 number. Right, yeah, click example 2. Yeah, you get there? All right, so 0.2 times the 35 cell, so A2 is the name of that cell. And then what was the y-intercept? Plus 38. So you do equals, is how you start off a cell. When you type equals, that means the spreadsheet is expecting you to type in a formula. So equals 0.2 star A2, and you can either get A2 by clicking on it, or you can even just type A and then 2, and it'll turn it orange and it'll highlight that plus 38. Hit enter, and I get a residual. Whoa, a residual of 45? That's kind of big. Yikes. Yeah, and then we can click and drag it down, or if you're awesome, double click that. It didn't work. There we go. Now I got it. I clicked and dragged a little bit, and it'll copy it down. Now these are the y values. You can compare the predicted ones to the actuals, right? Now let's find the residuals for these. How far off were these? So to find the residuals, I'm going to go equals at cell D2. And I'm saying let's take the actual y value, which is B2, minus the predicted y value, C2. Hit enter. -3. So that was off. It was down by 3. Let's drag that down and look at our residuals. Now, one thing I want to show you is that with these residuals, go down just below the table. All right, like cell D10 here. Type equals. I want to show you something. Type the word average, A-V-E. Whoa, look at this. It's like popping up a bunch of formulas here above us. I'm going to type average. I'm going to use an average formula. So whether I type it out or select it from that list, you type average and then open parentheses. Let me know if you guys need help. And within that average, watch this. Take your cursor and highlight your residuals. And you can see that it says D2 colon D9. All right, I'm going to just walk around. That's all. All right, so you can close parentheses. You can also type it. D2 colon D9 or just click and drag all over there. And then hit enter. It'll actually even add the closed parentheses if you forget to. You got it? And so the average is 0.6. And in general, the average of these should be really close to 0 compared to the other ones, right? These residuals were somewhere at 3, 5, 3.6, but they kind of balance out even closer to 0 because we were trying to have the same number above the line as below the line, and that's why they should kind of balance out, average out to be about 0. Okay, let's graph these residuals. Do you guys remember how? Select your X column down to 9. Let go after you click. That's what I forgot to say last time. Hold Control, and then click and select your Y column, like so. Oh yeah, I hit Control B, or if you select a cell, you can make it bold, you can change the color, you can change the background, right? You can do all sorts of things, right? Look, I just made both of those columns yellow. All right, you can do a bunch of stuff. But with both of those columns selected, let's insert and make a scatter plot. And you guys are getting faster at these, right? So chart types, I don't want a pie chart. I don't want a line chart. I don't want a bar graph. Yeah, you can. Here, I'll help. I'll help. Let go. Hold. All right, so highlight the first one. Now it's let go. Hold Control. And now while holding Control, highlight the next column, not including the 0.6. There you go. Insert chart. Good, we good? We got our charts? Okay. So, I'm not going to take the time to make these points bigger or smaller. You make a scatter plot. And, yeah, so select scatter plot from the list. And here we go. So, these residuals, and then hit done. And then let's look at this graph. So let's see. So for these residuals, oh, wow, that's interesting. Because the residuals form like an upside down U shape, it actually suggests that the data might not be linear. That's interesting. So a line might not be the thing that best represents this, where I'd rather have kind of a bunch up and down. Notice that this is kind of like funny swoop, right? It's kind of like going, So it means that this might not be represented best by a line. So the equation doesn't necessarily model the data well. Also notice like that, right? We had some residuals up at 5 and 3-ish and 3.2-ish, right? So the line isn't it's not the best fit. The model doesn't fit the data well. Right, because those residuals are bigger numbers, and then I didn't even realize to look for that. That's an interesting type of analysis, is we'd be looking for points kind of like all over ups and downs, but that is intriguing. All right, let's see. I think we might, let me show one more thing. I actually talked about interpolation, extrapolation. Let me skip down just before example 5. All right, and I want to talk about correlation and causation. And this will be the last thing we do. All right, so flip a few pages, and we won't need the spreadsheets for this. It says when a change in one variable causes a change in another variable, it's called causation. Causation produces a strong correlation between the two variables, but the converse is not true. In other words, and you've probably heard this phrase before, correlation does not imply causation. Okay? Correlation does not imply causation. All right, and I want to show you some examples as to what I mean by that. Okay, so it says, tell whether correlation is likely in the situation, and if so, whether you think that one is causing the other. So it says time spent exercising and the number of calories burned. Right? I would expect those to have a correlation. Yep, we're good. And I would expect that, do you think exercising causes more calories to be burned? I would think so, yes. And there's a causal relationship, right? All right. But notice this next one. It says the number of banks in a city and the population of a city. There's probably a correlation between them. But notice that building more banks won't make more people. Right? I think you guys agree that's not where babies come from. Right? Banks are not the thing that produces more people. All right, so those are the 2 ideas. Thank you for hanging out. Have a great day. Bye-bye.